Hello guys, today we're going to discuss some problem based on some example. Actually, it'll be based on the one that we discussed just before this, that is operation on a real number. Okay. Actually, we already discussed about operations on real number, adding two rational. What is the outcomes or what is the results after adding two rational number, and what is the outcomes or what is the results after adding two irrational number. Okay. So this kind of problem, as we already discussed, an operations on real number. So today we are going to solve it, some numeracy based on that. Okay. For that, we are given with example 12, that is check whether 7 root 5 comma 7 by root 5 comma 2 root over 2 plus 21 comma pi minus 2 are irrational number or not. So we have to check this for that is this one, this 1 2 3 4. Okay, and this we have to check it whether it is belong to irrational number or not. In order to check it, we have to know that after findings or after solving this, if we got additional expansions which is non-terminating and non-recurring, then we can conclude that this number or this real number belong to irrational number. Okay, and even in this case, if we got the divisible expansions which is non-terminating, non-recurring divisible expansions, then we can conclude that this number or this real number belong to irrational number. Okay, likewise we have to do even in this true. If we got the same, then we can conclude that it's belong to irrational number. All right, then let us proceed to this. So firstly, let us write what is the values of root 5. So the values of root 5 is 2.236. Okay, let us take up to this. Do the divisible expansions or do the values of root 5 goes on like this. But let us take up to this for our easy calculations. Let us take up to this. Okay, then what is the values of root 2? Values of root 2 is 1.4142. Okay, and even this, it will goes on like this. Okay, we took up to 1 2 3 4, that is for decimal place. Then let us proceed to pi. What is the values of pi? Values of pi is 3.1415. Okay, so it will goes on like this. Then what is the problem that we are going to solve? The problem that we are going to solve is 7 root 5, this and even this and this. Okay, we have to put the values that we wrote here. We have to put here, and we have to solve it, and then we have to check the result whether it is non-terminating, non-recurring or not. Okay, if it satisfies that condition, then easily we can say that this real number belong to irrational number. All right, then here we simply write the values of root 5. Okay, the values of root 5 is 2.236 and the values of root 2 is 1.4142, and pi is how much? Pi equal to 3.1415. Okay, so we're not going much further than that about how to find this root 5, root 2 and pi. Actually, all this problem basically we already studied or we already learned it in lower classes. Okay, so that's all for that's all for this. Then let us proceed to this problem. Okay, so what do we have? What is the question? That is 7 root 5. Okay, 7 root 5. What is this? 7. This is actually this is rational number and this is irrational number, so we have to multiply irrational number with a rational number. Okay, then we have to check it the outcomes whether it is belong to rational or irrational number. We have to check that. So what is the values of root 5? The values of root 5 is 2.236. Okay, so what is this? This is dot represent that, dot indicate that the divisible expansions, that is 2.236, goes on like this. Okay, So let us multiply these two. So if you multiply these two, then how much will you get? 6, 7 times how much will it be? That is 42. 4 in hand. 7 times 3 will give you how much? 21. Plus 4 will give you 25. 2 in hand. Okay. 7 times 2 will give you 14. 14 plus 2 will give you 16. Alright. 1 in hand. And 7 times 2 will give you how much? 14. 14 plus 2 will give you 15. So let us check here. How much have we got? That is 15 point 15 605 15 15652. Okay, that's what we got here. And then our answer will be 1 point, since there is only one point. Okay, after this decimal expansions, how many number is there? 1 2 3. Okay, let us start counting from here. 1 2 3. Okay, that means 15.652. Here how much will we write? That is 15.652. Okay, since the number or the decimal expansions is unending, or it goes on like this, so I have to proceed it like this. We have to keep it like this. All right, then we have let us check this decimal expansions. Here it is 15, here it is 652. Since the numbers or the decimal expansions that we got, it is not repeating itself again and again after the point. Okay, but moreover it is non-terminating. Okay, it will goes on like this, and it is non-terminate. It will goes on like this, and it is non-recurring or non-repeating decimal expansions. So this kind of decimal expansions, which is non-terminating as well as non-recurring decimal expansions, came under the properties or came under irrational number. Okay, thus we can conclude that 7 into root over 5, the values of 7 root over 5 is irrational number. Okay, then let us proceed to this. That is 7 by root 5. Okay, so here how to proceed this problem. Firstly, here we are given with some real number. Okay, here it is real number as well, but this is rational and this is irrational. Okay, so if you find this kind of problem, or if you find some real number is written like this, then you will have to multiply with root 5 by root 5. Okay, what is this? What is the properties of this? This is known as rationalize the denominator. Okay, that means here it is root 5, here it is root 5, here it is root 5. Okay, so this root 5 you have to make it, or you are going to make it in rational number, or you have to make it, or you have to break this root. Okay, so that this number can be called as rational number. Okay, then let us proceed to that. So if you multiply this two, then it will become 7 over 7 into root 5. Okay, and if you multiply this two, then it will become root 5 square. All right, so if you got square and root, then what will it be? 7 root 5 divided by how much? That is 5. Okay, so let us divide, let us separate a little bit so that our calculation can be a little bit easier. Okay, so 5, just divide 7 by 5. 5 one time is 5. 7 minus 5 will give you how much? 2. Okay, here there is point, so we can add zeros. Here 5 times 4 will give you how much? 20. Okay, that is 1.4. Here let us write what is the values of this 7 by 5. The values of 7 by 5 is 1.4. Okay, so we have to write it here 1.4. And what is the values of root 5? You have to write it, the values of root 5 that we wrote here, that is 2.236. Okay, just multiply these two, then whatever result that you've got, that will be the answer for this. Okay, that we have to check that whether it belong to rational as well as irrational number. Okay, we have to check it that both of them, the outcomes or the result will satisfy any one of them. Okay, whether it will be any one that is irrational or rational number. Okay, so 2.236, 1.4. Okay, 6 times 4 will give you 24, 3 times 4 will give you 12, 12 plus 2 will give you 14, then 4 times 2 will give you how much? 8, 8 plus 1 will give you 9. Okay, so 4 times 2 will give you 8, and 6 times 1 will give you 6, 3 times 1 will give you 3, and 2 times 1 will give you 2, 2 times 1 will give you 2. Okay, so let us add this. 4, 6 plus 4 will give you 10, and 9 plus 3 will give you how much? 12, 13. Okay, 1 in hand, 8 plus 2 will give you 10, 10 plus 1 will give you 11, 2 plus 1 will give you 3. Okay, let us take into account the points or the number that is written after this point. Okay, here how many number is there after this point? That is 1, 2, 3, and here how much it is? That is 1. Okay, so in addition to this, or let us add this to that means 3 plus what will give you 4. That means in the answer we have to take the numbers just by counting, or just by start counting from here. 1, 2, 3, 4. Okay, you have to put the points here. So this is the outcome. So this is the result that we got after multiplying 1.4 with 2.236. Okay, what is that? That is 3.134, 3.1304. Okay, since the number is repeating, since the number is non-terminating, so it will go on like this. Okay, let us check this. See, this is a number, or this is the decimal expansions which is non-terminating. We can easily know that it is non-terminating because here the decimal expansions that we got in root 5, it is non-terminating. Even when we are multiplying with 1.4, then also the decimal expansions we got will be non-terminating. Okay, that what is the next that we are going to check? That is whether it is repeating or non-repeating. Okay, let us check this. This is 1304. Okay, so it is not repeating, then we can say that it is non-terminating. Okay, non-repeating. Thus we can conclude that these decimal expansions belong to these decimal expansions belong to non-terminating, non-repeating decimal expansions. Okay, this kind of decimal expansions belong to irrational number. Okay, then what is this? What is the next problem that we have? That is root 2 plus 21. Here let us write root 2 plus 21. So what is the value of root 2? The value of root 2 is 1.4142. Okay, dot. Actually the values of root 2 will go on like this. Okay, the values of root 2 is we just took, that is 1.4142. Okay, even after that the values of root 2 will go on. Okay, plus how much? That is 21. So just add these two, and whatever the sums or whatever the values that you got after adding this one and this, that will be the results for this. Okay, so let us add here 1.4142. Okay, so you're going to add 21, so let us add 21.0000. Okay, that is 2414. 1 plus 1 will give you 2, 22.4142. Okay, 22.4142 dot. Okay, that is, it will go on like this. Even in this, the decimal expansions that we got, it is non-terminating and it is non-repeating. Okay, thus we can conclude that even this real number is also belong to irrational number. Okay, then what is the next? That is pi minus 2. Here we are going to check pi minus 2. Okay, so what is the value? What is the values of pi? That we have to know it first. Okay, pi value is 3, that is 3.1415, 3.1415 minus 3.1415, and the values of pi will go on like this. And we have to subtract 2 from values of pi, okay, minus 2. So if you subtract minus 2 from this, then how much will it be? That is 3.1415. Okay, you have to subtract 2 from this. If you subtract 2 from this, that means just add 0 so that you can match with the number just after this point. Okay, just add zeros. Okay, so if you add these zeros, then it can be matched. Then let us subtract 2 from this number. So 5141. So 3 minus 2 will give you 1. Okay, 3 minus 2 will give you 1. That is 1.1415. 1.1415. Okay, since it is non-terminating, so it will go on like this. Okay, we can see that the decimal expansions that we got after subtracting the values, after subtracting 2 from values of pi, it is non-terminating. Okay, and moreover it is non-repeating. Thus we can conclude that this is also belong to irrational number. Okay, so let us take into account all this thing, or let us check this all this thing. Okay, even this, it is belong to irrational number. Even this, it is belong to irrational number, and this belong to irrational number. This belong to irrational number. So by taking all of this, we can say that the given, okay, the given example or the given real numbers which is given for us to check whether it is belong to irrational number or not, that is irrational number. Okay, we can say that by taking all of this, we can say that it is irrational number. Okay, so whatever the values that it is given here, all this belong to irrational number. Okay, that we just calculate, or that is we just compute here. All right, is there any kind of difficulties in understanding this? Please, if you have any kind of difficulties in understanding this, please comment down below. Okay, this is all about for example 12. Then let us move to example 13. So in example 13, we're given with this real number and this. Okay, so we have to add this and this number. We have to add this and this. Okay, so what how to add? We have to check, we have to do that. Okay, firstly let us write 2 root 2, 5 root 3. What is the question? That is, the question has said that to add. Okay, then we just put add, then root 2 minus 3 root 3. Okay, so let us break this bracket. 2 plus root 2 root 2, 5 root 3 plus, what is this, root 2 minus 3 root 3. Okay, so let us check firstly whether there is similarity, whether there is some numbers or some numbers that we can add. Okay, so here is 2 root 2, here is 5 root 3, here is root 2. Okay, here is minus 3 root 3. Okay, we can take this 2, this one and this. Okay, so just bring this root 2 in here so that we can add easily. All right, plus, what is this, 5 root 3. Then let us bring this one in here. Okay, so what is the common that we got here? That is root 2 root 2. So let us take root 2 here. So root 2 times 2 will give you 2 root 2. Okay, plus root 2 times what will give you how much? Root 2. Okay, so what is the common that we get, and then that we can take? That is root 3 root 3. Here we can take root 3. Here it is 5 minus how much? 3. All right, so root 2, so 2 times, if you plus 2 and 1, then how much will you get? That is 3. So root 3, 5 minus 3 will give you 2. Okay, so if you multiply this 2, that it will be 3 root 2, and what will it be? That is 2 root 3. Okay, that is the answer for this. Okay, or you can write this answer even in this form. Okay, that is 2 root 3 plus 3 root 2. Okay, there is no problem for that. Okay, even if you put in this one in that, or even if you put this one in that. Okay, so the answer will be same. That's all, and that's okay. So this is all about for example 13. Okay, if you don't have any difficulties, or if you don't have any problem regarding about this thing, then let us move to example 14. So what do we have in example 14? That is what do we have in example 14? That is multiply 6 root 5 by 2 root 5. So you have to multiply this with this. Okay, that is 6 root 5 by how much? 2 root 5. You have to multiply this two. Here let us take 6 root 5 into 2 root 5. Okay, then 6 times 2 will give you how much? 12. Okay, so 5 root over 5 root 5 into root 5 will give you root 5 whole square. Okay, square and root cancel. 12, here is multiplications, so let us write like this. So if you multiply this root 12 and 5, how much will you get? 12 and 5 will give you, if 12 times 5 will give you 60. Okay, so that's it. That's the answer for this question number 14. It's easy. This is all about for example 14. Now let us proceed to this example 15. So what do we have in example 15? That is, we have to divide this number by this. Okay, by how much? 2 root 3. Okay, therefore the one that you are going to divide, you are going to keep this one in upside. Okay, divided by 2 root 3. So let us cut here. 2 times 4 will give you how much? 8. Okay, so 3 times root over 5, okay, will give you how much? 15. Since root 3 into root 5, if you multiply this to, how much will you get? That is root over 15. Okay, you can cut this one. That means the answer will be this. Okay, that is 4 over root 5. 4 into root 4 root 5. Okay, so this is all about the problem based the problem or the problem of some example based on operations on real number. Okay, so this is the last part for this problem. That's all for today. Thank you.